Welcome to 01 Nexus, where we simplify technology and bring the future to your fingertips. From the latest innovations, AI breakthroughs, and digital trends, to how everyday tech actually works, we've got you covered. Whether you're a tech enthusiast or just tech curious, you're in the right place. Have you ever wondered how your phone knows exactly where you are? Whether you're using Google Maps, tracking a delivery, or finding your lost phone, it's all thanks to GPS. But how does it actually work? In this video, we'll break down how GPS technology works. From satellites in space to signals in your pocket. Let's dive in. GPS stands for Global Positioning System. It's a network of satellites, ground stations, and receivers that work together to determine your precise location anywhere on Earth. Originally developed by the U.S. Department of Defense in the 1970s, GPS was meant for military use, but by the 1990s, it was open to the public. And now it's in nearly every smartphone, car, plane, and ship. Today, the U.S. GPS system has at least 24 active satellites, orbiting about 20,000 kilometers above the Earth. Your phone or any GPS receiver calculates your position using a method called trilateration. Not triangulation, which uses angles, but distances. Here's how it works. A GPS satellite sends a signal with the exact time it was sent. Your receiver notes how long it took the signal to arrive. Since radio waves travel at the speed of light, your device can calculate the distance to that satellite. But one satellite alone is not enough. You need signals from at least 4 satellites to accurately determine your latitude, your longitude, your altitude, and to correct any timing errors. GPS relies heavily on precise timing. Each satellite carries an atomic clock accurate to a billionth of a second. A tiny error in timing, even 1/millionth of a second, could lead to a position error of 300 meters, almost 1,000 feet. Since GPS receivers can't carry such accurate clocks, they solve for timing differences by using a 4th satellite, helping synchronize everything perfectly. GPS is incredibly accurate, but some factors can throw it off, including atmospheric interference. The ionosphere and troposphere can bend or delay signals. Obstructions. Tall buildings, dense forests, or tunnels may block signals. Multipath errors. When signals bounce off buildings or terrain before reaching the receiver. Satellite geometry. The relative position of satellites can affect accuracy. With good conditions, GPS can be accurate within 3 to 10 meters. And with differential GPS or RTK, real-time kinematic, used in agriculture or surveying, accuracy can reach centimeter levels. GPS powers much more than just maps. You use it when getting directions on your phone, tracking your fitness run, calling a rideshare, navigating a plane or ship, playing augmented reality games like Pokemon Go, operating drones or autonomous vehicles. It also helps in disaster response, military operations, and even in precise timekeeping for financial systems and power grids. Did you know GPS isn't the only system out there? Other countries have their own versions. GLONASS, Russia. Galileo, European Union. Beidou, China. NavIC, India. These systems can work together for better accuracy and reliability. In the future, GPS may get more satellites, better ground control, and AI-based error correction, making it faster and more precise than ever. So the next time you check your location, remember, it's not magic. It's satellites, timing, physics, and engineering all working together above your head. If you found this video helpful, give it a like and subscribe for more tech explained simply. See you on the next one. Thanks for watching.